Now you're to the point in evaluating your result where you need to calculate the confidence interval. This is the last thing that you need to do before moving on to the interpretation of your finding. Calculating a confidence interval is a pretty straightforward thing because you've already done most of the calculations of the numbers for the numbers that you need. To calculate the confidence interval for a one-sample z-test, you need to know the mean of the population, the standard error of the mean of the population, and the z-score that falls at the 95% level of probability, which we've already determined to be 1.96. You'll recognize that as your critical value for this test. So to determine the lower limit of the confidence interval, you simply take the mean, which is 1,538, and you subtract from that 1.96 times the standard error of the mean, and that's to get the lower limit. Let's draw a line here so it's clear what we're doing. And the upper limit will simply be 1,538 plus 1.96 times the standard error of the mean. Right? Very simple math. So of course, following our order of operations, we want to first multiply 1.96 times 18.67, and we get 36. We'll round that to 60. And now this becomes 1,501.4. You could say 0.41. And this becomes 1,574.59. So your confidence interval for this problem is, and you would write this in the following way, 95%, you could say CI for abbreviation, equals 501.41 to 1574.59. Got it? Now, your book explains what this confidence interval means, and let me just try to review that briefly with you. You've determined in your test that there's a statistically significant difference between the mean of your sample and the population mean of students who were not exposed to any kind of SAT preparatory class, correct? So by determining that there's a statistically significant difference, you are suggesting that the mean of students who have the preparatory SAT classes, that mean comes from a distribution of scores that's distinct, that is different from the population, the general population of scores that you've compared it to. Presumably students, a population that includes a majority of students that did not have a preparatory course. But you don't know the mean of this new population that you've identified. You only know the point estimate, that is the mean of your sample. So the confidence interval is telling you 95% of the time what is the range of means that you will obtain from that new population based on your sample statistics. So this is, in effect, a test of the precision of the estimate of your population. Now, how do you interpret this? Well, usually people are concerned with how broad this range is. And what you want to ask yourself is, on the lowest end of this range, how close does this mean come to the population mean that is known that you're saying this differs from? If this interval is very, very broad, the actual difference between this lowest number, or if the example is going in the other direction, it could be the higher number as well. But in this case, let's talk about the lower number. If this lower number is coming so close to the known population mean that it raises questions about whether or not this is a meaningful difference. Now, I'm not talking about statistical difference. I'm talking here about practical, meaningful difference. You need to address that in your interpretation.